So welcome everybody. Thanks for joining us. This is our third Leaving Cert Chemistry webinar. I'm Conor Walker and I work with the Folan's Post-Primary Publishing team. And I'm happy to be joined again tonight by our Chemistry Live authors, Declan and Ryan. So this evening, we're going to do mainly a deep dive into the higher level paper 1, the sample paper from the SEC, where we'll examine each question on that paper and look at suggested questions or suggested answers to each of those questions. So, Ryan, if you could maybe just go back to the previous slide there.
Yes.
So the webinar itself is one of the many supports that we're offering to teachers as part of our new Chemistry Live teaching package for the new Leaving Certificate. And for those of you who are not familiar with the teaching package, you can find out more about that if you go onto folans.ie and search for Chemistry Live, or you can obviously contact your local rep for some more information. Next slide, please, Ryan. We've also got some exciting updates or news for you with regard to Chemistry Live and both Real World Physics. We're delighted to announce that we're in partnership with COG, translating those books so that they're available to schools for the next academic year. So Declan a cara beit fa cúpla focal ará in Gaelga lenar múntúir uliachta.
Conor gaf me le scéal a gur mágút as a bheith obair le cog chun chemic bio agus physic don réin nua astú go Gaelga. Tá cuinte go méid anás ar bhúntóirí atá ag múin in a chemic agus na physica tríbhán na Gaelga cópt an leabhar astratha a bheith ar fáil dóibh. Gur míle mágút sa Conor.
Míle mágút freisin, Declan. To the next slide, please, Ryan. So the areas that we'll be covering today, there's quite a lot to get through, so we'll see how time pans out, but I think we should be able to cover it all within the hour. So covered in the presentation, Ryan will first give, and Declan, an update on our digital resources. So this will include an update on where we stand with our PowerPoints. There's been a revamp of the ones that were already there, and then we've delivered the balance of those resources online. So Ryan's going to just give you some sample slides from that and to talk about what our further plans are around the digital that he'll be working on over the summer. And Declan's going to also cover some new demonstration videos that we've recorded with the assistance of Lennox Educational, which will explain use of instrumentation, digital instrumentation for chemistry. Then after that, we will do the deep dive into the sample paper where Declan and Ryan will go through each question and their suggested approach to answering each. And then there'll be a Q&A slot at the end of the webinar. So if you want to post any questions into the chat, maybe as we're going through the paper, maybe just jot down your comments or questions. And then when we get to the end of the paper, then you can perhaps post the questions in, and that will allow us to consolidate all the questions together and answer as many as we can during the Q&A. And if we don't have time, what we'll do is we'll extract all the important questions that you ask and we'll create a document where we respond to those questions and we'll circulate that post-webinar. To make you aware also that we're recording this webinar and a link will be shared with everybody attending here today. After that happens, we should get that maybe tomorrow. And the same, we will be making the PowerPoint slides for this presentation available tomorrow after the webinar. So that's it from me for now. What I'll do now is disappear for a short while and I'll hand you first over to Ryan. Best of luck, Ryan.
Thanks, Conor, and hello everybody. So I'm going to talk to you today a small bit about just an update on the digital resources. So where are we at with the resources? So all 26 chapters of Chemistry Live now have a PowerPoint. In addition to that, all previously completed PowerPoints, so I had a selection of PowerPoints created about 10 PowerPoints, give or take, for fifth year material. They have all received a refresh, meaning that the language is a lot more simplified, it's a lot more visual, the slides are cleaner, and there's experiment videos now are linked to each PowerPoint. And I'll give you an idea of that in a moment. And just a reminder that some of the other digital resources that are on phones at the moment, so that the numerical answers and solutions for both the textbook and workbook are available on Folens, as are the schemes of work, as are the experiment videos for every experiment, and suggested lab apparatus and chemical lists. So the next couple of slides are just indicating, giving you more of a flavour of what the refreshed PowerPoints look like, because the first set of PowerPoints were really only a draft. So you can see that the slides are just a lot more cleaner looking. There's a lot more images on the slides, very high quality images and so forth. There's videos, as I was saying, for each of the experiments. So the way the videos work for this is there's a QR code if students want to use their phones for the QR code. But more importantly, for the teacher, all you have to do as a teacher is just come over here to this, where this movie icon is on the left hand side. And if you click on that icon, I won't do it now because it'll interrupt the presentation. But if you do click on the icon, it will open up a web page that will directly bring you to the video. It actually opens up the video directly. So I have that done for each of the videos, each of the experiments, because all of our experiments, as you know, in Chemistry Live, have a video associated with them. I've also done a bit of work in terms of the mathematics side of it. So most of the slides now that contain, or chapters that contain questions involving maths and so forth, now have it written in such a way that you have step 1 and step 2. So like, for instance, this is a simple enough question. I just said I'll start off easy with this. And you've got step 1, step 2. This gives students a chance to manipulate the formulas themselves, give them an opportunity to carry out the formula. And then all teachers have to do is click on the next slide, and it will bring up the answer for them, so they can then move on then or even assess their students to see how well they did with the problem. So again, this is a very simple one, but just for the sake of the webinar, I said it was easier to keep this as simple as possible. But that's been done for all the mathematical equations that are in Chemistry Live, particularly in the volumetric chapters, and as well as thermochemistry and so forth. So that's what's been done to date. All of those resources have been sent to Folens. They are going to be shortly uploaded onto Folens, and I presume there'll be an announcement on social media, on their Instagram and Facebook, to let people know when those refreshed, all 26 chapters are up on Folens. For me to complete over the next few months. So I did say this at the very beginning, that I wanted to do some Canva presentations, and that it's more for students as such, and they're just, again, written in such a way that it's a bit more student friendly for them. The creation of online videos. So very similar to what I would have done from the Conical Flask. I'll be doing this for the 3rd edition of Chemistry Live. And again, those videos will link straight back into PowerPoints and Canva. A new aspect that I'm working on this year, and I've already made a start on this, is the Chemistry Live posters. And there'll be information on these. So these will just be posters that you can actually print for your room in either A4, or if you want to go larger, to A3, and they'll contain information on it. It could be on specific chapters or topics. So for example, it could be something on Bohr's theory, to give you a flavour of that. It could be a diagram in the middle, and then there could be, again, the text all around it and so forth. But again, it'll be in a very much of a poster format, very aesthetically pleasing as such. In addition to that, as you know, this is our 3rd webinar of this year. So Declan and I made a promise to everyone at our first webinar that we would continue on the webinars going into 2026, 2027. So we'll discuss future webinars at a later date. The next slide now is going to be bringing Declan in, and he'll be discussing the Lennox videos.
Grand.
Declan.
Thanks very much, Ryan. Now, as you're aware, in the new curriculum specification or syllabus, there's a lot of emphasis on students gathering primary data. And on the next slide, we show we have 4 new experiments on the Folens website, just showing students how they can collect data quickly and accurately to bring the whole topic of London dispersion forces and hydrogen bonding to life. On the next slide, we'll see you can get these wireless temperature sensors, which connect up to a laptop. And what we've done in this video is we've taken 4 organic compounds, and at the bottom there you can see that there's a bit of filter paper on the sensor. We immerse that in each of the 4 compounds and compare the rates of evaporation. And on the next slide, Ryan, we see, so for example, in the case of pentane and hexane, and all of this is explained in the video to the students, we see that we have London dispersion forces in operation there, but for the alcohols, they have much higher rates of evaporation, much higher boiling points, and hence lower rates of reaction, rates of evaporation. So the alcohols, therefore, are much higher up in the graph. The next one then is a simple way of Boyle's law, demonstrating Boyle's law. And on the next slide, we show a simple gas syringe to demonstrate Boyle's law. And on the next slide, we show the data being collected from Boyle's law. And then we can draw our very simple conclusions about how, at constant temperature, the volume of the gas is inversely proportional to the pressure. Then on the next experiment, now you will note that buffer solutions are not mentioned anywhere on the syllabus, but in one of the sample papers, there was a question on buffer solutions. And of course, it shows that they're examining the practicals in very great detail. So in this experiment, we show how to calibrate the pH electrode. And that was the question that was asked. And there I'm holding the pH electrode there and carrying out the calibration before you can start using it. And calibrating it at 4 and also at, say, 10 would be essential. So minute detail being examined on the curriculum regarding the calibration of pH sensors. Thanks, Ryan. And then the final one, then, there was also an experiment on the sample paper about monitoring the pH changes that occur when an acid-base titration occurs. And we have there the experimental setup, the titration in the beaker. We give precautions for the students when they're using these sensors, because these sensors are quite cheap, and they've now replaced, sensor technology has replaced the old pH meters, and we bring the students through the changes in pH. And then on the next slide, we show the students, that if you carried out a titration and measured the pH on the next slide there, Ryan, you can see, that if you actually, the previous one was just versus time, but if you carried it out accurately and measured the volume after each one, you will get the titration curve as shown there on the screen from Chemistry Live. Great, Ryan. Thanks very much. So now what we want to do is to go through sample paper 1 for you in detail, give you what we think would be an acceptable answer. Now, these, of course, are just our own opinions on it. We will keep going through the questions because everything is in writing. And it would be very helpful if you held your questions until the end and we can handle everything as Connor says. And even if there isn't time at the end to answer all of the questions, we will answer them in writing for you. Now, Ryan will handle the technology and he'll also jump in, if you wouldn't mind, Ryan, jump in if you see me forgetting anything. or if you see me making any mistakes, Ryan, I know you'll spot them all. Grand.
No problem,
Thanks very
Declan.
much.
Can you see the
So
screen,
let's
Declan?
That's perfect,
Yeah.
Ryan. Absolutely great. Okay, so let's get started. So on our first question, right? This question dealt with emission spectra. I uh, the, the EM minus EN, more commonly E2 minus E1, but the students will be able to see very clearly that EM is the energy of the electron in the higher level, energy of the electron in the lower energy level. F is the frequency of the light emitted. They might look for that word emitted, in the marking scheme. Now, there was a bit of a problem in the next one. Now, if you look on page 17 of the syllabus, it says that students must be able to identify 3 emission line spectra. These are sodium, strontium, and copper. Now, the reason why these 3 were specified is because they can relate the spectra to what they observe in the flame tests. So the flame test for sodium, for example, gives out yellow light. Therefore, the sodium spectrum has just a single yellow line. Well, in fact, 2 very narrow yellow lines very close together, but they look as just one single yellow line. Now, likewise with strontium, because they see the brightest crimson color of the strontium, sometimes even bright red, they can relate that to the reddish color. And that's the spectrum there, spectrum Y, as shown on the screen. Now, there is a problem with X because X, the only other one they can ask is copper. Now, I wouldn't worry about this. This was a bit of a typo. Uh, I looked up the link that they gave on the SEC sample paper to where they got that spectrum from, and it was actually wrong on the website. So it's just a minor glitch. By the way, so far I've spotted, even in Chemistry Live, there are about 5 typos. We'll be collating them all and putting them on the website. So glitches do happen, and as long as you're aware of it and make students aware of it. Okay, so element-wise strontium is fine. Now, the next question then was a question on Hess's law. I remember receiving a question from a teacher some years ago asking me why didn't I include in Chemistry Live the other way of solving problems on Hess's law. For delta H reaction equals sigma delta H of the reactants minus sigma delta H of the heats of reactants of the reactants. Now, the reason I didn't include that was because it was very clear to me when marking Leaving Cert papers that students who use the second method do not do as well because there's more likelihood of them making mistakes. So in Chemistry Live, I've only included the method that is shown there on the screen. Now, I marked Leaving Cert papers for 20 years, and you'd notice in some centres in the old days when you'd have an envelope full of papers that the students who used the sigma delta H formula didn't do as well as the students who use the method in Chemistry Live. So you can see there the method on the screen. By the way, when Ryan and I were working on these sample answers, we wrote them so that the teachers yourselves could use them in the classroom when going through these with your own students. So we wrote out the answers in sufficient detail that they mirrored the way that the answers are done in Chemistry Live itself. So in case you're wondering why we put in so much detail, we've put in the detail really to benefit the students who will be reading this. Grand. Okay, so it's a very straightforward question. I don't think there'll be any problems, with Hess's law calculations. Generally, students do very well in these types of calculations anyway. Right. Next question then, ionization energy, straightforward, just the definition, no problem there. Then explaining exceptions. Now, one of the things I learned from my 20 years of marking leaving cert chemistry papers was that students often lose marks because they don't provide enough detail. They don't write enough. Now, to give the SEC their credit, they allow plenty of space for the students to write in the answers. So the sort of things they'd be looking for there would be beryllium filled to S sublevel, extra stability, therefore more energy required. Likewise with nitrogen, half filled 2p sublevel, extra stability, therefore more energy required. That should cover all the points required in any scheme. Now, a lot of emphasis in the new syllabus in the whole area of bonding. If anything, that area has been expanded, and I think students will do well in it. Now, explaining there why ketones are very soluble in water. Again, simplified diagrams, and the students need to point out very clearly the imbalance in the charges in water and the polarization of the C double bond O group, and very important then to show where the hydrogen bond arises. Now, the question was very well phrased, and overall, I thought this was a very fair paper because it did tell the students precisely that they needed to show one molecule of propanone, one molecule of water. They needed to show the displacement of the charges, and they needed to show the intermolecular forces between the specific parts of the molecules. So it was very clear to the students what they were required to show. So a great question. Right. Next question then. So
Just
please,
to
Ryan.
just interrupt there, Declan,
Yeah.
for one moment, just for people watching or who might have joined late, that the AEG there stands for the Assessment and Exam Guide, page 221. So just when that does come up, as you know, that the organic chapters are in the back of the essentially the workbook, but it's classed as the AEG.
Yeah.
Thanks, Declan.
Thanks, Ryan, for reminding me of that. And the reason we put the organic chapters in the assessment and exam guide was because it freed up space in the main textbook to give lots more worked examples and also to give model answers to many past exam papers and questions, also model answers that came from the SEC sample papers. Now, the next experiment is similar to what was in the old syllabus. Again, the important thing to stress with students when they're describing how to do experiments is to number each step because that will force them to think. And generally speaking, students lose marks easily when describing experiments. So key points would be, for example, finding the mass, crushing the tablets, making the paste, rinsing, very important, pestle and mortar rinse, make sure everything is washed into the beaker, then stirring the mixture, then being taken care to transfer everything into the volumetric flask, add all the washings. And don't forget to emphasize to your students, they must use the word invert. If they use the word like shake the volumetric flask, no marks, because you won't get your homogeneous mixture unless you invert it about 20 times. So keywords like that, like invert, absolutely essential. Next question then, organic chemistry. Again, very straightforward. The UPAC name, compound hexanol, uh, classification of the alcohols, straight out of the curriculum. And, I would congratulate the SEC. There were no huge surprises on the paper because they stuck very closely to the curriculum specification or syllabus. Grand. Then writing the condensed structural formula for compound B, very straightforward. Now, here is where students will have to do a bit of mental gymnastics because they'll be jumping from organic back to bonding and so on. And that can, give rise to a bit of a problem for the students. So they need a bit of practice as a result. Why does the bond angle in water decrease? And it's all about, of course, the increased repulsion. So that point there is important, explaining why it's really less than 109. You'd expect it to be a perfect tetrahedron. So that's great, Ryan. Next slide now, please. Grand. Okay, the next one then, as we know, a new experiment on the syllabus is the preparation of ester using the reflux method. In the old syllabus, as we know, it was just a test tube preparation of ester. Now it's a full-scale preparation of ester. So the ester methyl ethanoate, drawing the molecular structure, no problem there. The other product is, of course, water. Now, here's an interesting question. State an advantage of using the reflux conditions during the production of an ester. So the students want to be very clear that you have to heat up the reactants to speed it up and to get it to occur within the space of 15 or 20 minutes. But also, you don't want the flask to run dry because you're dealing with organic solvents. So how much of what's in the box they would expect is interesting. If they would expect, that the heat will speed up the reaction, that should be sufficient really, because it is an advantage. But I would recommend to students that if this comes up, that they mention both points about the loss of the reactants because they're of a volatile nature. But a good question, very good. A new area of the syllabus then is this whole area of surfactants and the reactants needed to produce soap. Now, this is one of the new experiments on the syllabus. And again, we shot a video of this in the Eureka Lab because the syllabus specifies that soap must be made with home products. So it's not the traditional reflux method that we had in the old syllabus for the preparation of soap. Now, describing how soap works as surfactants. Now, a good way to do this would be to get students into the habit of drawing diagrams. And always remind your students that drawing a diagram gives them a great advantage because of the fact that they can pick up extra marks from a diagram. Now, you can see there on the screen the diagram that the artists in Folens, and they did a great job. It required a bit of working with them, but a nice simple diagram showing the hydrophilic part of the soap molecule on the outside and the hydrophobic part of the soap molecule on the inside. And if you like, it's sort of dragging apart then the oil droplet into tiny globules. So if they forget some of the points, we put them there in the form of bullet points. If they were to leave out some of those bullet points, they could still get the marks from the diagram. So a simple diagram like the one shown on the screen would be perfect. Grand. And then other applications of surfactants, yeah, okay, in firefighting, foams, they're using emulsifiers in our mayonnaise, in ice cream, and so on, pesticide sprays. Any one of those would be perfect. Right. Next one, then, we're on to bonding. And we can expect to see, I think, a lot of bonding questions appearing because there's an emphasis in the curriculum on the continuum of chemical bonding, bonding as a continuum, as a sort of spectrum. Uh, so this question was quite straightforward. Magnesium and its formula, and why is it classified as an ionic compound? Well, the whole key to that is because of the electronegativity differences being greater than 1.7. No problem. Then arrangement of electrons for chloride ion, no problem. And why is that a stable electron configuration? Well, this is sort of question has turned up on past exam papers and referring to the fact that it is the same electron configuration as the nearest noble gas. Argon in this case is perfect for full marks. Then explaining why magnesium chloride is highly soluble in water. Now, uh, the whole idea there would be ion dipole attractions. That would be the key word because they're mentioned specifically on the syllabus. So strong ion dipole attractions sufficient to overcome the strength of the ionic bonds and pull apart the crystal and separate the ions. So no problem there. Grand. Now, electrochemistry. You will have noticed that electrochemistry is now much more emphasized on the new syllabus. I would also point out to you that I would recommend that electrochemistry should be the last chapter that you would cover. The reason for that is because so many concepts in electrochemistry depend on previous concepts like bonding, like, for example, the whole area of oxidation and reduction, electron transfer. Students generally, all the research shows us that they find electrochemistry a difficult subject. So by delaying it until well into sixth year, you're doing them a favor. Now, uh, magnesium metals produced justify your answer, okay? And it's is it produced at the anode or the cathode? Now there is one thing that I would recommend you get your students to learn off, and that's the acronym ROA. So reduction takes place at the cathode, oxidation at the anode. Now that holds whether you're doing electrolysis or whether you're talking about galvanic cells. So if they can remember that inside an exam, it'll help them. So there we see that magnesium is picking up electrons, so it's reduction. Therefore, that must be happening at the cathode. Okay, great. Now, then they go on to galvanic cells. Now, again, this is a new area for the syllabus. And again, thanks to Folens, they sent down their camera crew and we set up a galvanic cell and we went through all the background theory of it in the Eureka Labs in UCC. And I think you'll find it very helpful to look at that video with your students. Now, this is a case where they're asked to explain. And so they would be looking for several points, Now, oxidation at the anode, reduction at the cathode, even those 2 points are bound to be worth some marks. Where electrons are flowing, the importance of the salt bridge, and the reactions happening in the oxidation reaction and the reduction reaction and the overall reaction. So if you take this in stages with your students, they'll get it all right. Now, this is where a diagram can summarize everything. And there's a very nice piece of artwork in Chemistry Live. Thanks, Ryan. That's exactly the one. Now, get your students to study that because the visual learners will get enormous help from this. You can see there on the left where the zinc has been oxidized and the electrons are flowing from the zinc. You can see on the right the copper being reduced and electrons are flowing into the copper. And because oxidation is occurring at the zinc side, then the zinc must be the anode. And because reduction is happening at the right-hand side, copper must be the cathode. Okay, so that will help our students. Now, Ryan mentioned earlier on that we'll be doing more CPD events next year, and we'll definitely be zooming in one of those on electrochemistry. Great. Thanks, Ryan. Next slide, please. Okay. Now, this is where we have calculations. Now, you will have noticed in Chemistry Live in the third edition, there were 2 new chapters. And those 2 new chapters dealt specifically with calculations. And if you look at chapter 13, I have the book here next to me. Chapter 13 deals with key formulas for solving volumetric problems. And we give 4 formulas. And with those 4 formulas, if the students can remember those 4 formulas, they can handle anything that's thrown at them. Okay, so if we look here firstly at the magnesium chloride, calculating the mass of magnesium chloride, again, we put everything down in terms of steps to bring them through it. Obviously, when the students are doing this themselves, they won't be calling out step 1, step 2, step 3. But hopefully, this will be of help to you in your teaching of the students how to approach these problems. So that was quite straightforward. The mass turns out there is 9.1697. We don't know how many decimal places they're going to be looking for. We just don't know. So for the moment, I think until we get further advice from the SEC or from IDA, then I would suggest you just tell the students to put down what appears on their calculator, unless they're told to bring it to 2 or 3 decimal places or whatever. The next one then is calculating the minimum volume of the acid to completely neutralize that massive magnesium hydroxide. Again, step 1, fairly straightforward. Again, using the formula to calculate the volume of the HCl, rearranging, and out comes the volume. Okay, so quite straightforward. Now, part 3 was a bit lengthy, but again, if they break it down into steps, they'll get there. This is where they're asked to calculate the concentration of the magnesium chloride solution when that volume calculated in part 2 is added to the 22 grams of magnesium hydroxide. So, and they give the density of water as 1 gram per cubic centimeter, and that density formula is formula number 4 in Chemistry Live on page 226. Right. So again, if they break it down into steps, step 1 is straightforward stoichiometry. Step 2 is calculating the volume using the formula density is mass over volume. Step 3 then is calculating the total volume. This was a bit unusual. They've never given a question like this before. So calculating the total volume of solution was fairly straightforward. And then in step 4, calculating the concentration of the magnesium chloride solution. Again, fairly okay, again, using one of the 4 formulas. And if they do that, the answer drops out fairly neatly. Okay, so a bit lengthy, but if the students break it down into each separate step, they get there. Grand. On to the next question then about hydrogen peroxide. Much the same as what we've met before. Average rate, very straightforward. We'll show you the graph and instantaneous rate in a moment. Very straightforward. Why does the rate decrease? Now, it's interesting now what they might look for. I would suggest that you would explain this in terms of the lowering in concentration and also in terms of the fewer successful collisions, because the collision theory is on the new syllabus, and so they could be expected to refer to it. Okay, and then we look at the graph in a moment, but look at the 5th question there. Describe how the catalyst could be more effective. Okay, well, increasing the surface area is an obvious one, or increasing the temperature would be another one. Grand. Okay, and they were asked then to show on this. Okay, and again, it's straightforward, measuring the instantaneous rate You know, in the book we show you just sorting the triangle. Ryan did this diagram, and it's just measuring the slope, but everything is fine. You can put in the little triangle lines or just calculate the slope as shown. But again, very straightforward. And thanks, Ryan, for your artistic ability in getting that there on the screen. Fantastic. So nothing new there compared to the old syllabus. Now, calculate the volume of oxygen produced when the sample of peroxide decomposes completely at standard temperature and pressure. Now, again, break it down into steps. Calculating the mass of the hydrogen peroxide, very straightforward. Calculate the mass of the hydrogen, convert the mass of the hydrogen peroxide to moles. Again, very straightforward. And then looking at the mole ratio. And finally, then in step 4, converting in moles of oxygen to volume of oxygen, 2.47 litres. So quite straightforward. I don't think students would have much difficulty there. Okay, next question, very straightforward. Lovely question to see forensic science being brought in. Okay, oxidation number of -1. The balancing of the equations, fairly straightforward. Hydrogen peroxide, the oxygen going from -1 to -2. Each molecule therefore loses 2, so you need 2 Fe2 pluses, and balancing up the hydrogens and oxygens, you get the equation at the end. Very straightforward. Lovely question. Okay, question 5. Now, even though the treatment of water has been on the old syllabus, in the new syllabus, there is an increased emphasis on energy consumption. And we'll see now how this comes up. The first thing there on flocculation, very straightforward. Explaining why it's carried out, because if it wasn't, the water that we would come out of our taps would look quite cloudy because of the suspensions. Now, a new area on the syllabus is microplastics. Now, describe how microplastics could come to be in our water supply. Now, the water supply could refer to either the raw water that might come from a local river into the water treatment plant, or it might refer to the water that comes out of our taps. So I suggest we include reference to both of them. So how do microplastics get into our rivers and lakes? Okay, and we can see there's synthetic clothing and tire wear, personal care products are full of all these microplastics and so on. And in many cases, they may not be removed in the water treatment plant because they're so tiny that they can get through the sand filters. So that was a fairly straightforward question. Then ultraviolet treatment, a new topic on the syllabus. Again, exposing the water to ultraviolet radiation to kill microorganisms. Quite straightforward there. Thanks, Ryan. Okay, what's an advantage of using ultraviolet treatment instead of chlorination? Well, we're not adding chemicals to the water, and so you don't have chlorine residual. That's a term that the engineer, you'll see in the book there were some photographs of Inniscarra water treatment plant, and when I went on a walking tour of that with the engineer, he spoke about chlorine residuals. So it's something that might turn up chlorine. Although I love to smell the chlorine from tap water because you know then that it's safe to drink. But one of the advantages of ultraviolet is that you don't get the smell of chlorine, so you're more environmentally friendly. Now, I mentioned then about the importance of energy consumption in water treatment. And in the question there, they talk about solar panels and they describe how this is used to reduce carbon emissions. Well, then we're not burning fossil fuels, and so less carbon dioxide is released. Quite straightforward. And if you didn't have solar panels, what's another way of reducing carbon emissions? Well, there are a number of ways I could think of, and that are in Chemistry Live. You could use, for example, wind energy, windmills at them, or now they're using more and more sensor technology to detect leaks. so that the sensor will give out a signal which they can pick up on their system and pinpoint that there's a leak underground in one of their areas. So therefore, the pumping system will use less electricity the less leaks there are. Okay, or also in some plants that have been designed, they built them on a hill so that the water coming in is fed through the system under gravity. Chemical equilibrium question, very straightforward. Kc, very straightforward. Calculating the value of Kc, a nice question, very clear. I think students will have no difficulty with that. Great. Next one then, Le Chatelier's principle, nice question. Then sodium hypochlorite added. Will the pH increase, and explain your answer? Now, again, emphasize to students, this word explain should always turn off alarm bells that they need to get into detail. So the first point, I'd say there'd be 4 points, that the NaOCl, sodium hypochlorite, it dissolves in the water. So the concentration of the hypochlorite ions are increased. Then, from Le Chatelier, equilibrium shifts to the left to reduce the concentration. This shifting reduces the concentration of H plus ions, and therefore the pH increases. So 4 points there that need to be emphasized. Great, Ryan. Thanks very much. Okay, acids and bases, fairly straightforward. Distinguishing between an acid and a base, a strong acid and a weak acid, no great problems there. Identifying pH titration curves, fine. Again, this is one of the model answers we've given in the textbook, so we've just cut and pasted there from page 380. Unusual for them to produce pH curves going in the opposite direction to the way they'd normally be produced, but nothing great problem there. Why is the pH meter better than universal indicator? Because with the pH meter, or the pH sensor to be more accurate, it gives you an actual value, and you don't have the subjectivity of deciding on color changes. And then the variable, of course, is that the concentration of the acid and the base must be kept constant throughout all 4 different titrations, to compare like with like. Next one then, why do we need to use a standard solution? Well, the students want to explain what a standard solution is and why it's important, because it allows us to measure the concentration of an unknown solution. The number of moles of XaOH, again, using the formula there. Perfect, Ryan. Next slide there, please. Okay, the piece of equipment, the burette. And next slide there, please, Ryan. How many moles of HA did the students add? Okay, again, 1-to-1 ratio, very straightforward. And calculate the concentration of HA. Again, one of the formulas we give in Chemistry Live chapter. And that chapter, there's a calculations for acid and base. And I may not have mentioned, there's also a specific chapter for calculations in oxidation and reduction to give students practice in using one of these 4 formulas. And then calculating the pH then is quite straightforward, 4.81. Okay, and now we're on to nearly there, on to our last question, straightforward. Major industrial use of hydrocarbons, very straightforward. Now, this is an interesting question, part 2. Draw the molecular structure of cis-butene, including all atoms and bonds. Now, this was a good question because the examiner clearly told the students that all atoms and bonds, so they couldn't just write down CH3 as we normally write. They had to write C bonded to H, C bonded to H, C bonded to H, But it's a nice question. One of the new topics on the curriculum is the whole area of cis and trans isomers. Again, why do they have similar heats of combustion? Because you're talking, since they're isomers, you have the same number of bonds, same bonds being broken, okay, and the same bonds being formed in the products, okay. So two important points there. Grand. A balanced chemical equation for the combustion, very similar to the old syllabus. Explain why it has a high activation energy. Now, this is the great advantage. I would recommend every student have these molymod molecules, because when teaching the cis and trans isomers, get the students to build the cis isomer and the trans isomer, and they'll see from the molymod that they cannot rotate around the double bond. At room temperature, there's continuous rotation around the single bond, but not the double bond. So the idea of energy conversion there. And why but-1-ene doesn't exhibit geometric isomerism, because of course you must have different groups for geometric isomerism. Great. Thanks, Ryan. I think we're almost there, Grand. And this is the preparation of ethene, a labeled diagram. Again, the main thing to emphasize to the students is that it doesn't have to be a beautifully drawn diagram like you see on the screen there, a simple black and white diagram, but make sure that everything is labeled. And then when ethene is bubbled through potassium permanganate, the solution becomes colorless. Explain why this happens. Well, again, there are 2 points, and there's a bit of mental gymnastics here for the students again. The double bond means it's unsaturated and it's oxidized by the potassium permanganate. You know, the ethene is oxidized. Now, why does it become colorless? Because the permanganate ions are reduced to colorless Mn2 plus ions. The actual oxidation reaction is not on the syllabus. You actually form ethane 1,2-diol, ethane 1,2-diol, or ethylene glycol, as it's often referred to. But that's not on, so they wouldn't be looking for that reaction. But the reduction of the manganese 7 to manganese 2 would definitely be there. And the final question then on reaction mechanisms, very straightforward, no problem there. Same really as the old syllabus. Okay. And I think we're nearly, is that it, Ryan?
Just the last one there,
Are
Declan,
we on?
IV.
Oh yeah. One last question. Yeah. State the UPAC name produced, and that's 1,2-dichloroethane. Right. So that is our whistle stop tour completed, and I'll hand you back now to Connor.
Fair play, Declan. There was a lot to get through there. I held off giving you any time warnings because you were making such good progress and I didn't want to cramp your style. Thanks everyone for your questions. A few of them came through during Declan's presentation, so I'm going to go through each and every one of them now. And perhaps as Declan's answering questions, or if you've noted questions that you'd like to pop into the chat now about any aspects of that sample paper, we can go through that too. So to begin with, from Olive, in relation to question 1D, do you need -2 for oxygen, or is it just enough to show that the oxygen is negative -1?
Yeah, that's the carbonyl. Is that a question? Could we show that on the screen there, please?
I can, Declan, 2 seconds now.
Right, yeah.
Connor, can you repeat the question again? It was question
Yes, so this is in relation to question 1D. Do you need -2 for oxygen, or is it just enough to show that the oxygen is negative -1?
Yeah. They just talk about to show that it's polarized. You see, if you look at what's on the screen there, the polarization for water, there we put in the -2 because we're showing the balance of the charge over the whole molecule. But when you're showing that a bond is just polarized, just a delta plus and a delta minus is perfect, as it's shown on the screen.
Thanks, Declan. I hope that answers it. Next question. What type of dashed lines are required to show hydrogen H bonding?
H bonding, yeah. The sort of dashed lines that we have are like what's there on the screen and what's in the book. The Now, once the students can draw some bit of a dashed line and label it as a hydrogen bond or hydrogen bonding, that's all that matters. There's no actual strict convention for showing hydrogen bonding, but usually in uh, intramolecular bonding is usually showed with a solid line, as we can see on the screen. But intermolecular bonding, like hydrogen bonds and so on, they're usually showed with a dashed line, any sort of a dashed line.
Okay. Next one is, do you know if the exam, no, hang on, there was one, sorry, apologies, there was a question there that I think I skipped over before I ask this one. I'll go to this one next anyway and see if we can find the one that I thought was to ask. Do you know if the exam papers will have the AR or elements on the cover page like they have previously?
Now, in the CPD events held by the Irish Science Teachers Association, that was a very strong request that came from the teachers. So when the submission is made to the SEC, I hope they will put the relative atomic masses on the front page, because it makes no sense for students have to be continuously referring to the SEC books of exam tables, you know. So I would hope, in response to that question, that the SEC will revert to the previous system.
Okay. There was also, Declan, I don't know whether you remember this, but a question, what, on a page reference, I think, what page in the book did Declan say the 4 formulas for calculations were on? Does that
Yeah,
make
I have
sense,
the,
that question?
yeah, it does.
227.
226.
76.
Yeah. Page
Okay.
226. I have the book here
Yeah.
next to me. Yeah.
Okay, great. Thanks, Declan.
226. Yeah.
Next, from Jude, I think this is, could you pose this question at the end, please? What is the best way of measuring initial rate of reaction from a graph?
Yeah. Measuring the initial rate of reaction, you should have a tangent at the 0 mark. Now, it's actually quite difficult to do manually, but if you look at the one that was there, and that's a new, I'm glad you asked that question, because that's a new area of the syllabus, initial rate. So you would have to draw a tangent there at the 0 mark to give you an idea of the initial rate. Now, I also explain in the book how you could do a rough method of initial rate, but the most accurate way is a tangent at the 0 mark.
Okay, thank you, Declan. This is the question I can answer, I think. So we're just asked to explain again what the red numbers at the side of each answer are in red. So correct me if I'm wrong, Ryan and Declan, but they are the page references to where the answers can be found in the textbook. So if you see P302 or P303, any reference like that is in reference to the textbook, a page in the textbook. And then if the answer is found in the assessment and exam guide, which is the case in some instances, you will see the abbreviation AEG, like Ryan shows there for question 7. So AEG, page 187, means that the answer can be located on page 187 of the assessment and exam guide. Is that correct?
Correct.
Yeah, great, thank you. All right, another question in. Is the formula method sufficient for calculating molarity in volumetric analysis, or should we still cover the first principles method?
Well, in the book, I've covered the first principles to show where the formulas come from. But the marking schemes have clearly shown that if the students show their work and the examiner can follow it and have all the points there using the formulas, they'll get full marks. So, judging from past exam papers, I see no problem about students using formula methods, unless they're specifically told to do the calculation, from first principles. but that's very rare. So the various formulas, those 4 formulas, will get them through everything.
Okay. I've just cast a final request out to people in our chat, just whether there are any further questions that they'd like to ask. Okay. Yes, we will be making the recording of this webinar available to all registered attendees tomorrow. And that's okay. We mentioned that at the beginning, and so if you joined late, you wouldn't have been able to do that. There's some questions just coming in relation to the project works and the AAC, and I think what we'll do is just, that was something that stands currently out of scope of this webinar, but certainly there are other topics and areas potentially of assessment which we could potentially look at further on down the road. And what I would suggest is actually in our survey, if you would like to answer the question with respect to what you would like covered in future webinars, that would help inform what we might cover when we kick off the second leg of all of these sessions, I suppose, when the next academic school year kicks off. So I think that's nearly it. You'll have seen there that India has posted a link to that survey that I mentioned. So if just before you log off, and I know we're pushing past 8 o'clock, if you could complete that short survey, particularly giving us feedback on Chemistry Live, the 3rd edition, what you like about it, or areas that you think we could potentially improve, what areas of support you might still require, and what you'd like us to cover in further webinars. We'd really appreciate that feedback. And that'll put you, if you do complete the webinar, it'll put you in the raffle for a €50 one for all voucher. So if you're not in, you can't win. I think I'll just do a final check of everything. I think that's it more or less in terms of questions. So without further ado, I'll start just closing off now. So Declan, Ryan, thanks very much again for such a great presentation, and you covered a lot of ground there, particularly through the paper in very short order. So that was great, and I hope that teachers found that beneficial. I'm sure that they did. And also for the people involved in organising this webinar, India, particularly behind the scenes, is running the show and keeping things working really smoothly. So we really appreciate your work, India. She's our webinar guru at this point. And
thanks, Connor.
No worries. And also to the Folan sales team, actually, who've been a huge help in spreading the word about this new edition this past year, and have helped to support chemistry teachers on the ground, and are a really important source of information to us and helping to understand what your needs are. So we really do appreciate that. And with that said, to everybody who joined us this evening, again, lovely evening out there. It's a very busy time of the year, so we really appreciate you taking the time to join us and for engaging with us. A lot of really good questions, I think, were posted, and we hope that we've answered them adequately for you. Of course, if we didn't, you can always maybe contact your Folan's rep or get in touch with customer service, and we'll be happy to come back with more answers to any questions that you might think of after this webinar. So I think that's it, more or less. We again would appreciate you completing the webinar. But that's it. 4 minutes past 8. We've done well, I think. We've covered a lot of ground. So thanks again, Declan, Ryan. Thanks, teachers, for joining us, and I wish you a very good evening, the rest of your evening. Thanks again, and goodbye.
Right. Lovely.
Thanks,
Thank you,
everybody.
Connor, very much. Good meet you, Mark. We've later.
So.